ladies and gentlemen, this is actually take 2 of this video because Mr. Bergman forgot to push record. Okay.
I'm not at all upset in any way about that.
Yeah. He's daggers of whatever. Okay, so last time we learned about how to go from grams to moles and moles to particles, particles to moles, grams, etc. But what we want to do is do a little bit more complex problem, Mr. Dimitrowicz. So let's just throw out a problem.
Yeah, so let's start off with, I'm a big fan of the 5.00. So we're going to go 5.00, and we're going to go grams of, what do you want to go with in this case here?
Nitrogen.
Nitrogen, we're going to make it N2.
Yeah, nitrogen is one of those diatomic molecules, so yeah, nitrogen, and I want to convert to particles. Now technically the particles are actually molecules because this is a molecular compound, non-metal to non-metal, and I want to go to particles, but we have a problem. I can't go from grams to moles to particles in one step. I have to go it in 2 steps.
This is us right here. This is me. I'm like a snowman.
So you
and we want to go all the way to here.
So we have to go first to moles. So again, we start with what we know is a fraction over 1, right? So 5.00 grams of N2 over 1. Now, we need to convert from grams to moles, moles to grams. So let's go ahead and write that. Do we leave this fraction, g over mole, x of g over moles, or do we flip it? Now notice we've got grams on top there, and we've got grams on top in the fraction. That doesn't work. So what do?
Flip it.
Flip it. All right.
So we're going to have grams of N2 right here, and we're going to have 1 mole of N2 on the top.
Now, we have to now find that answer from the periodic table. And N2 is an easy one to find the molar mass of. On the periodic table here, it's 14.007. So I'm going to take 14.007. Of course, N2, so you double that number, and you get 28.014. And one thing to note here is we like to pretty much round just to the hundredth place, 2 places. So I'd say 28.01. The 4 isn't necessary necessarily. So 28.0, we can leave the 4. It makes no difference.
And we get to cancel right
now.
now.
Let's play the cancel game. So cancel those out. But now all I've got is moles. So the next thing is I need to use my next fraction, and I have to ask the question, do I leave it or do I flip it? In this case, we're going to leave it because we've got moles on top, we've got moles on bottom. In the top one, leave. Now, Mr. Dimitrowicz, can we cancel something?
We love to cancel, right? So we're going to have our moles on the top and moles on the bottom, which is why we left it the same as it was, and now we're over here at particles.
So my calculator, 5 divided by 28.014 times 6.022. Now, on my calculator, I'm going to push the EE button. I never push the times 10 button. EE23, and I get the grand total of 1.0748 times 10 to the 23rd.
And we have to keep the units in here because
so that's going to be particles of N2. Now, significant figure-wise, we're going to keep how many significant digits? 3 there, more there. So 3 is the Bastion number. So we're going to round to the 3rd place past the decimal. So this is simply going to just be 1.07 times 10 to the 23rd.
Now again, let me remind you of what he said a little bit earlier, is that particles can be anything, right? In this case, since it's N2, N2 is a molecule because a molecule is 2 or more atoms together. Don't be surprised when you don't see the word particle in that problem, you see atoms or molecules or compounds or whatnot. So while I'm a big fan of doing a really easy problem for you to follow, we're going to do like the monster of all problems right now.
Monster problem. Okay. So what are you going to do?
Let's start with a compound that is kind of ugly. Let's start with what? Calcium phosphate?
Sure.
And we're going to start with 9.312 times 10 to the 26th particles of calcium phosphate.
So calcium phosphate. Now, one thing I might recommend that you do before you, because this is going to be a 2-step problem, we're kind of like 3 fractions in a row, is try and figure out what is the molar mass of calcium phosphate. But to find the molar mass of calcium phosphate, we have to add up the calciums and the phosphates, or we have to find the formula of the calcium phosphate. So calcium from the periodic table is in column number 2, alkaline earth metal, so his charge is 2 positive. Phosphate from our periodic table is from our polyatomic ion list, PO4 3 negative, and so now we have to, those don't add up to 0. So we're going to have to play this game, put Ca2 positive, I'm still not happy, that's 4 and negative 3, so add another phosphate, and then 6. We're almost there, give me another calcium, and then we have the answer.
So this would be Ca3
parentheses PO4 2. Now we need to find, because ultimately you realize we need this number, because that's what we're trying to figure this out. So we need to figure out, so calcium, so let me look up calcium on the periodic table. Calcium is, you can just draw a line underneath it.
By the way,
Calcium.
I didn't actually write what we were solving for. I kind of assumed here,
Oh.
we're starting at particles, and we
yeah.
want to go backwards to grams.
Yeah, so maybe
So I'm going to put a
gram.
little arrow to grams. I don't know if it can be seen in frame here. We'll learn very quickly.
Yeah. So calcium phosphate, calcium is 40.08. Phosphorus is 30.97. And we know oxygen, it's 15.999. So on my calculator, I'm gonna add those up or multiply.
Remember here, let's comment
Oh.
here. There's 2 phosphoruses because that 2 is multiplied by this. Isn't it 2 times 4? Aren't there 8 oxygens here?
Yeah, there's 8 oxygens and 2 phosphorus. So I said 3 times 40.08 plus 2 times 30.97 plus 8 times 15.999. Grand total of 310.17.
Now, I'm going to pause here for a moment here, lest you think that this was the first thing we had to do, because we know that we have to go here at the end. This is per 1 mole of the same thing. But we're actually starting at particles over
Yeah,
here.
that's
So
a good point.
our first step isn't going to be to convert to grams. So just like we did in the previous problem, now we're over here, we're kind of happy, and we know that we have to go all the way over here. Now, we just jumped ahead and started to do the
Yeah.
conversion right here, but that's probably bad form on our part. What we probably want to do is start from particles, and let's set up our table, because anytime that we don't know what we're doing, let's just start by putting it in our train tracks, because that'll kind of give us an idea of what we have to do next. So I'm going to go like this, 26 particles. I'm going to write part as an abbreviation of this, and I'm going to write the actual formula, since we know it now, is Ca3PO4 in parentheses 2. And I'm going to set it up in our train tracks. And here's one of the things I would encourage you on. Whatever we start you off with, look and see where you are on the table. We're at particles right now, so we are right here. Now, then the next thing I would do is say, what are they trying to have us solve for? And they're asking us to solve for grams. So we have to go from here to here. And the only way we can do that is by first stopping in a pit stop at moles.
So I'm gonna have to use this 6.02 number and we have to ask the question, leave it or flip it. Now, we've got particles on top, that doesn't work, flip it. So this guy's has to be flipped. So
6.022 times 10 to the 23rd. I'm gonna write PRT.
particles of calcium phosphate, yeah. And then you can cross off, what can we cross off?
We, with the light, cross off particles of this, and we end up with moles. So now we're right here, and now this comes into play, this
Now,
conversion.
so we wanna go one more step, and I think we're gonna run out of space over here, so we can do the next line right
So
here.
let's just pretend this
Yeah, keep.
zooms over here.
Yeah, and so I've got moles on top, and if we look at the table, or, you know, over here we got grams per mole. Do we leave it or flip it? We got moles on the top, I got moles on the bottom, that's what we want, so we leave it.
I'm gonna write it over here just so it's a little
Yeah,
bit
yeah.
easier to see. So we're gonna keep our grams on the top. So just pretend this is a continuation of the page we were just doing. And on the bottom, we're gonna have 1 mole of Ca3. Now, you may not like writing Ca3PO4 in parentheses 2, and to be honest, I've not enjoyed writing it even here. But when we start doing problems that are a little more challenging, this is gonna become a big deal that you have it written in here.
So I would encourage you guys to follow along on your calculators too, so that you're doing this and getting the same answers that I am. So I've just typed in 9.312, I push the double E button, and I'm gonna type in 26, divided by 6.022 double E 23 times 310.17. And I get a grand total of 479,625. And that would be what units?
Is it times 10 or? is
No,
it
there's
just-
no times 10.
All right, so it's just that, and the units are gonna be the only thing that's left standing here, because I did not cancel with the
Oh,
vengeance.
yeah.
Moles cancels here, moles cancels here,
So we've got just grams of calcium phosphate.
that's the only thing that's left. Now, if we take a look at this, there's some significant figure issues with this,
Yeah.
right? What do you suggest we do?
So we ask ourselves how many significant figures are in our numbers. Here we have 4, 4, and 5, so we're gonna go with 4. So let's find the 4th digit.
1, 2, 3, 4, we're gonna make our line of death right there.
So we're gonna have to round, that's gonna be 47,000.
And by the way, I've seen some people
400.
just write 4796 and go, all right, we're done. That's not the same thing as 479,000.
Yeah,
So
yeah.
we're gonna have to use some placeholders, right?
Yeah, and since this is a 2, that doesn't round this 6 up, so we just add zeros at it. So 479,600 grams of calcium phosphate. Now, you could also write this in scientific notation.
Yeah, and I would encourage, and it may be easier, because I'm not a big fan of writing in zeros as placeholders, but isn't this our applied decimal place? Can we go
Yeah.
1, 2, 3, 4, 5 places to
Yeah.
the left, and I could go 4.796, keeping the 4 significant figures, times 10 to the 5th grams of this. And it might be easier, either of these answers are gonna be okay. We just know how it's been working with GoFormative, where typically whatever method you choose is the one that we didn't choose. But you will still be given credit for either of these two answers.
Yeah, so that's how you do this. It's kind of an ugly problem, and I know we only gave you 2 examples, but you're gonna have lots of examples in class, and you're gonna get better at this. And honestly, guys, this isn't that hard because, well, part of it, we know that you guys are crazy smart. I mean, you're from Houston.
Clearly.
Right? So, yeah. Hey, guys, we'll see you in class.
Take care.